Yeah, she now rocking with Mr. Wit. A little flavor from Q Beats, you know that this a hit. Michael Jackson bad, yeah, this is it. A few months ago I was about to call it quits until I came across personalized math tutoring. FBT, the #1 solution. So what you waiting on? Everything is online.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about formulas. When you speak of formulas, you're talking about equations with purpose. That's right, when you're dealing with a formula, you're just dealing with a regular equation that may have one or many variables that has a purpose. It was created to do a job, and that's exactly what we're here to do today. So what this video will be focusing on is, one, evaluating formulas, and then more importantly, how to isolate a variable within a formula. In other words, solving for a particular variable within a formula. That's what we're here to do. So in problem number 1, we're dealing with the distance formula. That's right, distance equals rate times time. And in part A here, they want us to find the distance d when r equals to 65 miles per hour and t equals to 2 hours. So part A is an evaluation problem. They want you to find out the value when given everything you need in order to solve for the variable. So here all we have to do is replace r with 65 and t with 2 to find out our result. So I'll rewrite the formula using substitution and end up with d equals to 65 times 2. Alright, so you simply plug in the values and then do the operations that the formula is asking you to do. So 65 times 2 is 130, so I end up with 130 miles. Alright, that's it, ladies and gentlemen. You got it. Let's go ahead and box up this answer here. Box it. You got it. Done and done. That's part A. Alright, in part B, they're asking us to solve for r, the rate. So we'll start with our formula, d equals to rt, and then in order to isolate r, in order to solve for it, we're going to divide both sides by t, the time. That's right. So you'll end up with the rate being equivalent to the distance divided by the time. And that's it. So that's solving for r. All you have to do in a problem such as this is just get the variable that they're requesting by itself. Many times you won't have to plug in any values here. So what they're looking for is d divided by t. That's all they want to know in that problem, and that's what we gave them. Let's box it up. So boxing up the answer here, d divided by t, that's problem 1b as in boy. Alright, part C. Here we're asked to find the rate when we're given a distance of 15 feet and a time of 3 seconds. So all you have to do actually is grab this previous result here in part B, where we know that the rate is equivalent to the distance divided by the time, and plug in these values that we're given here. So I'll plug in our values here, and I'll have r equals to 15, the distance, divided by our time of 3 seconds, and then simplifying that, we will find that our result is 5 feet per second. And that's it. Done for problem 1C. And here we are, done with problem number 1, ladies and gentlemen. Let's move on to problem number 2. Alright, for problem number 2, we have an average problem, an average formula, which is also known as finding the arithmetic mean. The arithmetic mean is the same thing as finding the average. So here we have our formula, and we have capital A equals to lowercase a plus b plus c plus d divided by 4. In other words, we're finding the average of 4 values. Please note that a capital A in a formula is different from a lowercase a. These are 2 different variables. In addition to that, you may find in some formulas you have the same variable or letter. However, they'll differ because they'll have a different subscript. So it may be like V1 or V2 and V3, what have you. So keep in mind that any variation on a variable, any change in a variable, means that it's a totally different variable than the other. So keep that in mind when working with formulas. All right. In problem A here, it says to find the average, find capital A, when we have values of 12, 15, 17, and 14. So let's go ahead and plug that in and solve for it. So we'll start by rewriting our formula here by having A equals 12 plus 15 plus 17 plus 14, all divided by 4, which gives us a result of 58 fourths. When you divide this, you'll end up with a value of 14 and 5/10. So this is our answer for problem 2A. All right, so that's it. You just plug in the values and you do the operations. We found the average of those numbers, 14 and 5/10. Done. All right. In part B, they're asking us to take that arithmetic mean formula and solve for C. So to begin, I'll rewrite our formula and multiply both sides by 4. So it'll look like this. I'll have 4 times A equals to 4 times the quantity of lowercase a plus b plus c plus d all over 4. The reason why I'm multiplying by 4, ladies and gentlemen, is because I want to get rid of the fraction, all right, on that right side of the equal sign. See, my 4's are going to cancel out. Yeah, like that. They're gone now. So I'll have 4 times my capital A equals to A plus B plus C plus D. Just like that. Remember, we're solving for C. So in order to solve for C, you can do this in one step or multiple steps. But let's go ahead and see about doing it all at once on the next page here. So we're solving for C, so I can show that I'm going to subtract my lowercase a to both sides of the equal sign. And that'll bring down 4 times capital A minus A, which now equals to B plus C plus D. But remember, we're trying to solve for C, right? So that means that you're going to go ahead and subtract B to both sides, all right? And let's go ahead and condense this by subtracting D as well, all right? So that's a 2 for 1 in that last step. My B's will cancel out, the D's will cancel out, and I'll end up with a value of C that equals to 4 times capital A minus lowercase b minus D, and this is C solved for, ladies and gentlemen. And that's what you want to do. When solving for a variable in a formula, you want to isolate it, get it by itself. You want a positive 1 of that variable, and that's exactly what we have in problem 2B. All right, that does it. Boxing it up and on to problem number 3. All right. From here on out, we're going to focus on formulas and simply isolating the variable that they're asking for. So in problem number 3, what you have before you is you have the slope-intercept form of a linear equation. Y equals mx plus b, where m is equivalent to the slope and b is the y-intercept. Remember, a formula is an equation with purpose, and this one definitely has a purpose. So what we're going to do here is we're going to solve for x, all right? So I'm going to start by rewriting the formula as y equals mx plus b, and I want to get the term that has the variable that they're asking for isolated on one side of the equal sign. So that means I need to subtract b to both sides, all right, just like that. So I'll be bringing down y minus b, which now equals to mx. All right, and since I'm solving for x, the next thing I can do is divide both sides by my variable m. That's right. If I divide both sides by m, I can cancel out the m's on the right, and that will free up my variable x. So I end up with y minus b divided by m, which now equals to x, and done. That's it. My variable's isolated, and that's the answer. So here we have it. Done. Let's keep it moving. Next problem we have is problem number 4. This is the area of a triangle, ladies and gentlemen. Every formula has purpose. So here we have capital A equals to 1/2 b times h. In other words, the area is equivalent to 1/2 the base times the height. They're asking us to solve for b, which is our base. So let's start by rewriting our formula and then isolating the variable b. All right, so I have A equals to 1/2 b times h. That's right, bh. So what we're going to do, ladies and gentlemen, is first of all, get rid of this fraction. I don't want to see it. It's in the way. It bothers me. So one way I can always do that is by multiplying both sides of the equal sign. In other words, multiplying every single term by the common denominator of 2. So I'll rewrite this as 2 times capital A equals to 2 times 1/2 times BH. All right. From there, I'm going to cancel out the 2's on the right side. That's right, they're gone. Just gone. They simplify to 1. So therefore, they're no longer needing to be, it's just gone. Okay. So I'm going to bring down 2A now. Yeah. And I have 2A now equals to BH. And then I'm going to divide both sides by h. You got it. You got to get that h out of the way. So now that I have this, we have our base solved for. That's right. 2 times capital A divided by h is equivalent to the variable b. In other words, the base of the triangle. And there you have it. That solves problem number 4. Let's go ahead and box that up. Red boxing. All right, let's move on to our next problem. In problem number 5, we have negative 5x plus 3y equals 12. Ladies and gentlemen, you're looking at a linear equation right here. And they're asking us to solve for y, something that you'll be asked to do many times in your algebra classes and beyond. So by solving for y, we're going to be able to place this linear equation in slope-intercept form. So that's the purpose of them asking you to solve for y in a problem like this. So let's go ahead and do just that. I'll be bringing down that negative 5x plus 3y equals 12, ladies and gentlemen. You got it. And so here, I'm going to start by isolating the term with a variable y. So that means I want to get rid of that negative 5x. So I'll be adding 5x to both sides of the equal sign here, like so. I'll be bringing down 3y, which now equals to 5x plus 12, and from the here, I'm going to divide both sides by 3. That's right, each and every term I'm dividing by 3, so that I can simplify it. So we'll have y equals 5/3 x plus 12 divided by 3 is 4. And there you have your equation in slope-intercept form, ladies and gentlemen. This equation is the graph of a line, all right? And its purpose, it depends on what the creator designed it for. Many formulas are linear in nature, all right? So there you have it on problem number 5. Done. Here we have it. All right, moving on to problem number 6. In problem number 6, we have the formula for temperature to change the unit of measurement from Celsius to Fahrenheit. All right, this equation comes up quite a bit when you're dealing with formulas, ladies and gentlemen, so I'm glad we have it as part of the lesson today. So here we're asked to solve for C. All right, so let's do just that. We'll start by rewriting our formula. We have F equals to 9/5 C plus 32. We're solving for C, so I'll begin by subtracting 32 to both sides of the equal sign here. All right, my 32's will cancel out, and I'll bring down F minus 32, which now equals to 9/5 C. Because this formula is so popular, there's a certain way textbooks and teachers will prefer you to write your answer here. Instead of multiplying everything by 5 and then dividing by 9, yeah, they'll just want you to multiply both sides by the reciprocal of 9/5, which is 5/9. So it'll look like this. Let me show you. We'll have 5/9 times the quantity of F minus 32 equals 5/9 times 9/5 C. All right, as I had to multiply 5/9 to each term in our problem here. All right, so there you have it. So on the left, we have a distributive property situation, right? Which you should know by now is my favorite property in the world because I can get my arrows popping. However, most textbooks will stop right here. So that's exactly what we'll do. We'll stop with the 5/9 times the quantity of F minus 32, and then everything on the right side here will cancel out except for the variable C. So they'll want you to leave the answer just like this. I've rarely seen a textbook or teacher that would have you multiply the 5/9 within the parentheses with this formula. So what I'm showing you is specific to this temperature formula. This is the way it's usually written, so this is what you can expect to see. All right, that's the result. That's the answer. Done. Let's go ahead and box it up. All right, so I couldn't get my arrows popping on that problem. I'm really disappointed. Let's move on. All right, problem number 7, we have the area of a circle. So we have A equals to pi times r squared. Here we're asked to solve for r, so let's do just that. We'll start by rewriting the formula. I'll have capital A equals to pi times r squared, and the first thing I'll do here is divide both sides by pi. So dividing both sides by pi, remember pi is just a constant, it's just a number. So this is just going to be r squared equals to a divided by pi here. And then in order to solve for r, which is the radius by the way, you'll need to take the square root of both sides. Now, You won't need to use the square root property. You don't need to take the positive and negative versions of the square root of a divided by pi, because when you're dealing with the radius of a circle, it will never be negative. So therefore, you can just take the positive root here. So I'll just simply have the square root of a divided by pi is equivalent to the square root of r squared, and then when I take the positive root of this, I'll end up with the square root of a divided by pi, which equals to r, and that's it. Now, you could rationalize this if you like, all right? That's possible. So if I were to rationalize this result, I would have the square root of a divided by the square root of pi times the square root of pi over the square root of pi. All right, multiplying straight across, I'll end up with the square root of a times pi divided by pi. All right, and this is what r equals to. So depending on your textbook or instructor, you can leave the radius as the square root of a divided by pi, or you may want to write it as, without any radicals in the denominator, the square root of a times pi divided by pi. There you go. So depending on your teacher, instructor, textbook, either one of these will do here. All right, that's problem number 7. Done. Let's keep it moving. All right, here we have problem number 8, which deals with population growth, the formula for population growth. It is also a formula that is used with continuously compounding interest. We have the amount in the account is equivalent to the principal times e to the r, which is the rate, times t, which is the time. And they want us to solve for t here. That's right. So in solving for t in this formula, I'll start by rewriting my formula as a equals to p e to the rt, and then I'll divide both sides by p. All right. Remember, our goal here is to isolate t, so we're going to start by getting rid of anything we don't need. It's in the way. So I now have a over p is equivalent to e to the rt. Because this function is exponential at this point, I need to get rid of that constant e. I can do that by taking the natural log of both sides, so that's what's coming next. So I'll have the natural log of a divided by p is going to be equivalent to the natural log of e to the rt, like so. On the left, I'll bring down that natural log of a divided by p, and then on the right, the natural log and the e will cancel out, and I'll bring down rt, like so. From here, all I have to do is just simply divide both sides by r, the rate, and that will isolate my variable t, and it's done. That's it. So in other words, t is equivalent to the natural log of a divided by p all over r, and that's the answer. Let's go ahead and gift wrap this. There you have it, ladies and gentlemen. Done and done. That's time. Let's go ahead and move on to problem number 9. Problem number 9 is going to be about, what is problem number 9 going to be about? Here it is. Problem number 9 is the volume of a sphere. A ball. So what we're going to do now is start by rewriting this formula, shall we? We'll have v equals to 4/3 pi r cubed. That's what we got. And since I'm solving for the radius r, I'm going to start by getting rid of this fraction because it's ugly. It's in the way. So I'm going to multiply by 3/4. The reciprocal is always a fast way to get rid of a fraction in a problem, ladies and gentlemen. Just so you know. On the right side, the 3's will cancel out, the 4's will cancel out. I'm bringing down 3/4 v. I am enjoying myself right now, in case you were wondering. And next, I will be dividing both sides by pi. I'll be dividing both sides by pi. But first, let's do this. Let me do, you know what? I'm going to do a little something different. Let's rewrite the left side as 3v divided by 4. Same thing. Okay, which is going to be equivalent to pi r cubed, and then let's multiply both sides by 1 over pi. Yeah, I like that. So I'm multiplying both sides by 1 over pi. It'll look like this. All right, I want it to be clean for you. So this is me pretending to write things in a clean way. All right, so let's see what happens. On the left side, you just multiply straight across. You'll end up with 3v over 4 pi. Yeah? And then on the right side, your pi's will cancel out, and that will leave you with r cubed. But in order to isolate r, we're going to have to take another step. Let's move on to the next page. So once again, we have the 3v over 4 pi equals to r cubed. You're always solving for a positive 1 to the first power of your variable. That's not what I have right now. So that means I'll be taking the cube root of both sides of my equal sign here. So I'll have the cube root of 3v over 4 pi equals to the cube root of r cubed. All right. So once I have this, I can cancel out the cube root and the cube so that I know that I have my variable r solved for now. And our answer here could be the cube root of 3v over 4 pi. However, you have a radical in the denominator. So if you're asked to rationalize this, here's the process. You can break this up into the cube root of 3v over the cube root of 4 pi and then multiply the numerator and the denominator by the cube root of 16 pi squared. See, what you're trying to do in the denominator is create a perfect cube in the denominator there. All right. So what this gives you now is the cube root of 48v pi squared, and in the denominator you have the cube root of 64 pi cubed. All right. So what we'll do from here is we'll continue to simplify this, and you'll have the cube root of 8 times 6v pi squared all over 4 pi. All right. From here, you can take the cube root of the 8, which is going to be 2, times the cube root of 6v pi squared, which is all going to be over 4 pi. And then from here, you'll end up simplifying the 2 and the 4, so you'll end up with the following result. You'll have your radius equivalent to the cube root of 6v pi squared all over 2 pi. And that's it. There's your answer, ladies and gentlemen. All right, I hope that was just as much fun for you as it was for me. And remember, depending on your text or your instructor, they may let you slide with this version of the radius here. So all you have to do is ask to see if that's going to be admissible during a quiz or test. Okay? So there you have it, ladies and gentlemen. All right, in problem number 10, we have the area of a trapezoid. So here, let's start by rewriting our formula here. I'll have capital A equals to 1/2 the height times the sum of the bases. That's right. Notice that in this formula, we have base 1 and base 2. Those are the parallel sides of your trapezoid, and they're asking us to solve for base 1. So the first thing I want to do is get rid of this fraction, because it's ugly. So I can do that by multiplying both sides by 2. So let's do just that, multiplying both sides by 2. And here we go, here we go, here we go, here we go. The 2's will cancel out. Goodbye. Goodbye, 2. It's been real, but you had to go. That leaves us with h times the sum of my bases here. And from here, I'll go ahead and divide both sides by h. All right? That will free up what's inside of the parentheses here. So now that I have 2 times a divided by h equals to b1 plus b2, because my h is canceled out in that previous step, I can now solve for my base 1 by subtracting b2 to both sides now. So just subtract it to both sides. That's all you got to do. So you'll end up with your b1 being equivalent to 2a over h minus b2. And there you have it. That's the answer. Done and done. All right. That was fun. Next problem, number 11. So this is the sum, this is the amount that you would have in an account if you have placed in the principal amount and you have interest added to it. All right. So let's solve for P. That's what they're asking us to do. Let's go ahead and solve for P. We're going to start with our formula. A equals to P plus PRT. And notice that this equation, this formula, has our variable that we're solving for in more than one term. So when you encounter a situation like this, what you want to do is factor out the variable. That's what you want to do. So out of the 2 terms on the right of the equation, I have P in both terms, and what I can do is factor that P out. Okay, so this will give me 1 plus RT within the parentheses. All right, because remember, factoring is division, and P goes into itself once, and P goes into PRT, RT times. How do I know this? Because if I multiply back together, I would get the previous step. Now, to continue solving for P, all I have to do now is just simply divide both sides by 1 plus RT. And that's it. Just divide both sides by 1 plus RT. Hey, that's a decent T over there, all right? That's pretty good. I'm excited about that. So on the right side, my 1 plus RTs will cancel out. And so P, the principal, is equivalent to the total amount in the account divided by 1 plus the rate times time. All right, and there's your answer. So when you're trying to solve for your variable and you find your variable in more than one term, most likely you'll need to factor that variable out of those terms. All right, there you have it. That was problem number 11. On to your last problem, ladies and gentlemen. I know you're excited, right? Because I am. Problem number 12. Here we have another form of the temperature formula. All right, so I didn't want to leave you without showing you how to find out your Fahrenheit when given the Celsius. All right, so here we have Celsius equals to 5/9 times the quantity of Fahrenheit minus 32. Your Fahrenheit degree minus 32. And they want us to solve for Fahrenheit. So let's see what happens. What you'll do here, ladies and gentlemen, is start by rewriting your formula. You have C equals to 5/9 times F minus 32. Remember, the temperature formulas are really finicky when it comes to your textbooks and authors. There's a certain way they prefer to see the answer. So I'm going to show you how to solve it just for those textbooks. What you'll want to do first is get rid of that freaking fraction. All right, get rid of it. And you'll do that by multiplying both sides of your equal sign by the reciprocal of 5/9, which is 9/5. So I'll start by showing that I have 9/5 times C, which is equal to 9/5 times 5/9 times F minus 32. Just like that. Then on the right side, your 5s and 9s will cancel. Goodbye. Goodbye. Go die. All right, can't stand fractions. So I'm going to now bring down 9/5 C, which now equals to F minus 32. Yeah. All right, so things are looking up already. All you have to do now, ladies and gentlemen, are you ready? Are you ready? Is add 32 to both sides. That's it. Yeah, things are good now. 32s are canceling out. My Fahrenheit is equivalent to 9/5 C plus 32, and done. Son, that's it. Boxing it up. You got it. So, ladies and gentlemen, this is Larry Mr. Witt Whittington with Fort Bend Tutoring, FBT. Once again, asking you to rate, comment, and subscribe. This has been our formulas video. And as always, we ask you to donate if you can, because that helps us bring you more free math videos from me, Mr. Witt, and FBT. Peace.
So what you waiting on? Everything is online. Just hit the website, they even got FaceTime. Subscribe to the YouTube, request the video. Watch your math skills go from alright to incredible. They got math, got algebra, got geometry. Pre-calc, calculus, can't forget trigonometry.